Morning, my name's David Miller. I was a farm manager at Wheatsheaf Farming Company during its time as a strategic farm. We were 700 hectares of ground with 670 hectares of crop, and the aim of the strategic farm was for us to farm profitably, but also to look at the wider aspects of biodiversity, carbon sequestration, all the regenerative farm and things.
Hi, I'm Elizabeth Stockdale, head of the interdisciplinary farming systems team at NIAB. We've been working with David Miller since 2021 to support a programme of work on the strategic farm, looking at soil health, particularly the impact of cover crops, the impact of sort of pre-establishment management of soils, interacting with tillage, but also the wider impacts of the farming system on outcomes like nutrient density. Tell me about the farm, David.
Well, the farmers, it's a farming company. We farm for 3 different farmers, which is all in collaboration, all run as one. The soil type over there is we're free draining, so no land drains. It's over chalk, plenty of flints, reasonably light land, but we've also got some clay cap on top of the hills. We were a very conventional system up until 2010, and then we moved on to look at a more biological approach to it. So we started looking at cover crops in 2010. By the time we got to 2015, we'd gone to no-till, and from there, the combination of the cover crops and no-till, we started to reduce inputs. So that's sort of the journey that we've had so far.
And then you had a field you'd very recently taken in hand and brought into the regenerative journey. Do you want to just tell us about what it was up to?
Yeah, the field in question, Typhrees, was is from a separate landowner. He wanted us to take it on, and that had been farmed by a more conventional farming company before that. So there was quite a lot of soil movement, a lot of inputs across there. So it was really a very conventional field when we took it over.
And we started to monitor that as it came cover crops and then into spring barley, and then it went through a second cycle of pretty much the same thing. And we really saw both that field gradually changing and responding, though it's a slow process. But the thing that was really marked was the difference between the visual evaluation, just the way the soil looked basically in that field compared with those that had been managed regeneratively for a long time. A difference in organic matter, but that more important, the cycling of the organic matter changing the structure. So instead of being big square blocks, the soil was on the regenerative fields was much more like the crumbs, and the jargon of course is subangular blocks.
Yep.
That we see when the soil just breaks nicely into crumbs, and that's that biological processing of the soil really showing up the differences between those soils. The chemistry barely changed at all, but that physical structure, because of the better biology, really showing the change between that long-term regenerative and the field as it began its journey.
But also the infiltration rates were much greater there, so we could, the water would go through and remain in the soil for longer.
Yeah, and so that's that pore network. Really, we kind of, when we describe structure, we always look at the blocks and how the soil looks like. But the bit that really matters is actually how the pores work. I want to hold the water in the soil till it's there, till the plant roots need it, but also let it move through quickly when there's too much of it. So that balance between big and small pores is the heart of what makes really good soil structure.
Yeah, and that's really enhanced by worm numbers. The worm numbers increased greatly over the years we were looking at it. So yeah, they're worms and roots in the soil that just create this pore space, which is fantastic for the drainage. When we became a strategic farm, when you became involved, it was we just weaned ourselves off of the DAP, and that was really a case of, right, what can we do next to use the biological aspects to try and get our crops to establish better. They were already establishing better anyway, but it's a matter of what we were going to try and do.
Yeah, and was there anything that really did make a marked difference? So we looked at products with sort of slightly different modes of action, and all biological, so a humate-based material, a molasses and microbial-based material. We're not giving their names away, but nonetheless, different modes of action to try those different things going on both for winter and then for spring cereals, 2 years, having a look to see what happened. How were they to handle and use?
They were, yeah, we didn't have too much trouble with them. Some of the humate could have been a little cleaner to use. It was a bit claggy and blocked filters up and things. Um, but I think they were things that we could have overcome if we were going to use them
Yeah.
generally.
And I think that product sector has just been also learning itself, hasn't it, as it's been trying things out on farm. I guess the disappointing thing from our point of view is that when we looked at the products for those 2 years in this particular soil type, and we really saw no difference either in the crop establishment, but equally not in the soil populations or those relationships between the fungi in the soil, the mycorrhiza and the roots. And so we really did see no marked impact of those products in these seasons on this crop. I'm caveating lots because as a scientist, I don't like to make definitive statements, but absolutely we didn't see for the places we looked any real differences.
No, and I mean that was a fully replicated trial. It was it was done scientifically. We changed it a little bit in that we felt that the molasses-based product was intended not just as a something to put down with the seed, but was actually to be put on the crop as well. So we changed that. But as you say, we still saw no difference. We still had a dramatically bacteria-dominated soil. We weren't changing that balance whatsoever.
No, and I guess that's part of the population of the soil's really well adapted to its location, to the chemistry. It works with the physical structure. And one of the things we thought we were probably seeing was actually that you'd done such a good job over the previous decade of bringing the soils up. You might not be happy with the fungal bacterial balance, but actually the soil itself was fairly well doing a good job in terms of supporting the crops that were growing and how it was working. And that was really, really not really easy to enhance. It was pretty good anyway. So we also then started to have a bit of a look, didn't we, we did only just have a quick look at whether we could do something clever with intercropping or bicropping at the start of a crop's journey, whether that in that early phase of establishment, having some other roots around might make a difference.
Yeah, and I think that's we had very good sound reasons to think that it would work, that we'd had trials on the farm even before we became a strategic farm with South East Water, which we were looking at various cover crop mixes as well as doing nothing, which showed that from a South East Water point of view, we were capturing a lot of nutrients, but also when we started looking at the more intricate biology that's in there, we found that actually, in some cases, we could alter the balance of fungi and bacteria in the space of about 3 or 4 months. So nature was doing something that we couldn't replicate by using biological products. And so the theory would be that actually, if we can put a different set of roots in to act as a cover crop had done into a conventional winter crop, would that have the same effect? I mean, the reason that you want a fungally dominated soil is because that reacts so much different to everything else that you try and do to it. It's very much better at growing a crop.
Yeah, and I think there's something, of course, there's lots of different kinds of fungi in the soil, and when we do have more roots there, we tend to measure more fungi because we've got those root associated ones kind of really doing a great job, and we tend to measure them. Whereas when there isn't that diversity of roots that are there, they tend to be sulking and sitting in a corner and, well, why is no one being nice to us?
Yeah.
And so that we can change the way what we see because of the way we manage things. And that isn't necessarily a long-term change, but can be really beneficial. I think one of the things you did try was buckwheat. And one of the reasons we just want to want to mention that is, although we didn't see any real impact because it got frosted out really quickly, the idea of using buckwheat's got a really interesting set of roots that exude things into the soil that make phosphorus more available. It's one of the only plants, 5% of plants, that doesn't make its own arbuscular mycorrhizal association.
Yeah.
So to survive, it actually has this different way of making its roots and soil work, and it makes the phosphorus more available. And that's potentially quite an interesting thing in terms of the early growth period of crops when phosphorus isn't kicking around a lot.
Yeah, I think there's a lot of research that needs to be done into it. If that's going to remain something that people want to do, the research has to be there for Are you going to try and bicrop completely and harvest two crops? Do you need something that's a completely different species so you can take it out before harvest? All the various effects, whether it's a nitrogen fixing, whether it's a legume or whatever else. There's a real vast array of research that needs to go on to find out what's best. Something is better than nothing, but what's best?
Yeah, and I think we also saw that it was that people don't need to rush necessarily. They need to think very carefully about volunteers, but they don't need to rush to get rid of them. They can be that early companion. I mean, in part of our trial, we had a very good volunteer bean crop that did a really good job of being the bicrop we wanted, and you then were able to take that out in the spring. And so when we came along board, we kind of started to look a little bit in the cover crops and to see if we could think of or give good tools for understanding what made them good or bad. Because what you tended to see, and all of us do, was what's growing above ground.
Yeah.
So and a colleague of mine, Callum, will give him his due, spent an awful lot of time washing soil and roots to see what the differences were.
Yeah.
And we also kind of did those visual assessment blocks of soil, just getting a spade out and having a look. And a pity for Callum, we showed that, well, actually, what you saw above ground actually did tell you quite a lot about what was going on below ground. And if you really wanted to check, if you just got a spade out and just broke open the block, you could get as much as actually the hours he spent washing out roots. But really good data there to be really clear about the real benefits that the different kinds of roots of different cover crops were giving us in the soil.
Yeah, root architecture is a big thing. You're trying to put in different species that have long tap roots that are really going down and busting things up, as well as things like Phacelia, which has got a very fibrous root, which is much nearer the surface. But interestingly, when we first started, we were under the impression that we wanted a really high biomass cover crop on top, and we were getting cover crops which had got sort of 40 tons of dry weight. Of fresh weight per hectare of material, and we thought it was brilliant. But then we started to see the problems of actually we'd sucked up all the nutrients into that. We had no idea when they were going to come back, and also the problems with slugs and things like that. So
it's ground cover rather than biomass that's the really important thing. Yeah, absolutely. And then we followed that through into the next spring crop to see if there was any benefit of the different cover crops and what was going on.
Yeah.
It's just almost disappointing, but actually quite interesting when you go, oh, there were no big differences.
Yeah.
But actually, that's a really good news story there as well.
Absolutely. And I think that, with the different crops we'd had in those fields after the cover crops, whether it's spring barley or spring wheat or whatever, there was no difference in what we saw across those plots. But I think we're still, although we were saying no difference in yield's not probably the best thing to judge this by, as long as it's not worse. That incremental increase in soil biology, soil health, however you want to describe it, is carrying on all the time.
Yeah,
so that's really important.
And we absolutely saw that when we did that long-term comparison of the fields that had their cover crops and reduced tillage compared to the new field, Typhrees, coming into the rotation that hadn't. And the real difference in the quality or health of the soil, the structure was just so different. And the cover crops had a really key part of that in terms of building and contributing to the biological restructuring of those soils in conjunction with the appropriate timeliness of the management and crop growth.
Yeah, and I think if we look at where our organic matters had gone over the last 4 years, through putting no other amendments on whatsoever, no compost, no manures, nothing at all, incorporating some straw, but just through having cover crops in a rotation, we saw, our organic matters over 4 years went up 0.75%.
Yeah.
So that's one of those background things that actually will be really beneficial in the future.
And it's that regular input it doesn't have to be big amounts. We talked about not having huge biomass, but regular inputs is what keeps the biology going. It's feeding them regularly that really matters. And ideally, and we're standing in the sun today, the sun's energy fed out through the roots. And that's, of course, what cover crops do really well during their growing phase, using the sun really effectively in that late summer period and keeping the soils going.
Yeah.
Cool. Well, it's been really great to work with you. Thank you very much.
Thank you.